Good morning everyone. Myself K. Lakshmi, working as assistant professor in Narasimha Reddy Engineering College. So today you are going to see general characteristics of negative feedback amplifiers. So already in the previous class I have explained you basic amplifiers like voltage amplifier, current amplifier, transconductance amplifier and transresistance amplifier. You have seen ideal and practical characteristics of those amplifiers. So in this topic you are going to see what will be the effect of negative feedback on some parameters like gain, like frequency response, linearity. We know that AF equal to, from the block diagram we have written AF equal to, that is voltage gain with feedback is nothing but ratio of output voltage to the source voltage. Similarly, AIF equal to I naught by IS, GMF equal to I naught by VS, RMF equal to V naught by IS. Effect of negative feedback on transfer gain. So what will be the effect of negative feedback on transfer gain? We know that transfer gain of the amplifier is not constant as it depends on the factors such as operating point, temperature, etc. This lack of stability in amplifiers can be reduced by introducing negative feedback. So we know that the gain with negative feedback AF equal to A divided by 1 plus A into beta. Okay, differentiating both sides with respect to A we get. So lastly we get it as DAF by AF equal to DA by A into 1 by 1 plus A beta. So where DAF by AF is nothing but fractional change in amplification with feedback, DA by A is nothing but fractional change in amplification without feedback. So the factor 1 by 1 plus A beta is known as sensitivity of the transfer gain. Reciprocal of 1 by 1 plus A beta is nothing but a desensitivity. Okay, so in the expression AF equal to A by 1 plus A beta, if A beta is considered very much greater than 1, then A beta will be neglected, 1 will be neglected when we compared with A beta. So in that case AF equal to A divided by A beta, AA cancels and it will be equal to what? 1 by beta. So thus we can make gain independent of A. So reduction in gain, here it is given, see, AV prime equal to A divided by, AV prime is nothing but, that is voltage gain with feedback is nothing but AV divided by 1 plus AV into beta. So denominator is, that is AV into beta is very much greater than 1 means, so 1 will be neglected here, AV cancels, then it is nothing but 1 by beta. So thus we can make AV prime independent of AV. Increase in bandwidth. So with a negative feedback, actually lower cutoff frequency decreases and upper cutoff frequency increases by the factor FH prime is FHF, that is with feedback it is denoted by FH prime equal to FH into 1 plus AV mid into beta. Okay, similarly FL prime equal to FL divided by 1 plus AV mid into beta. So therefore with a negative feedback, so bandwidth will be increased because bandwidth equal to with feedback FH prime minus FL prime. Okay, so in the same way with a negative feedback we can reduce the distortion. So that is D prime equal to D divided by 1 plus AV into beta. Okay, so that means reducing means it will divide by the factor 1 plus AV into beta. Increases means it will multiply by the factor 1 plus AV into beta. So with negative feedback here gain is stabilized, the second parameter increases the bandwidth and the third parameter, so distortion will be reduced. Now coming to feedback to improve sensitivity, that is non-linearity will be improved, frequency distortion is decreased, bandwidth is increased. So that is with the feedback it is nothing but 1 plus A mid into beta into bandwidth. That means it is multiplied by the bandwidth without feedback. So here you can see the graph without feedback and with negative feedback. So without feedback here gain is high, whereas with negative feedback gain is reduced. Similarly, upper cutoff frequency increases with negative feedback, lower cutoff frequency is decreased with negative feedback. So this is the analysis by introducing negative feedback. So already we know the definition. Sensitivity is nothing but DAF by AF divided by, so mod DA by A. So it is defined as, that is mod DAF by AF divided by mod DA by A. So where DAF by AF is nothing but fractional change in amplification with feedback, DA by A is nothing but fractional change in amplification without feedback. So desensitivity is D equal to 1 plus A into beta. So reduction of nonlinear distortion, that is B2F equal to B2 divided by 1 plus A into beta. So B2F is less than B2, that is second harmonic with feedback reduces by introducing negative feedback. Reduction of noise. With negative feedback, noise will be reduced. That is nothing but whenever it will be reduced, it will divide by the factor 1 plus A beta. Remember this point. So NF is less than N. So NF is nothing but with feedback, N is nothing but without feedback. So with negative feedback, noise reduces. Noise is reduced with negative feedback. Next, transfer gain with feedback. So let us see the what will be the AF value. So with negative feedback, we should get AF equal to A divided by 1 plus A beta. Therefore, consider the block diagram as shown in figure. It consists of basic amplifier, feedback network, okay, and the comparator or mixture. So what is the input signal Xs? Like in general, we have represented with general parameters. So Xt equal to difference signal, which is equal to Xi. So Xi equal to, from this, Xs minus Xf, because it is nothing but we are introducing negative feedback. Next, here X0 equal to A into Xi. So AF equal to, so actually here from this figure, from the previous slide, so what is the basic amplifier? Here A equal to X0 divided by Xi. What is beta here? Beta equal to Xf divided by X0. So here say A equal to X0 by Xi as equation 1 and beta equal to Xf divided by X0 as equation 2. So here we know that A equal to X0 by Xi, which is equal to X0 divided by, what is Xi from this? Xs minus Xf. Substitute in the place of Xi, Xs minus Xf, then get X0 to the denominator, then it will be 1 by Xs by X0 minus Xf by X0, which is equal to 1 by Xs minus X0 minus Xf by X0 is beta. Now cross multiply, then it will be A into Xs by X0 minus A beta equal to 1. A into Xs by X0 equal to 1 plus A beta. Xs by X0 equal 1 plus A beta by A. We want X0 by Xs is nothing but A by 1 plus A beta, where AF equal to A by 1 plus A beta. So therefore, with the negative feedback, what will be the gain? So AF equal to A divided by 1 plus A beta. AF is nothing but gain with feedback. A is nothing but gain without feedback. If mod AF is less than mod A, the feedback is said to be negative feedback or degenerative feedback. If mod AF is greater than mod A, the feedback is known as positive or regenerative feedback. So now what do you mean by loop gain? Again, getting back to the previous slide. So all of you once look at the block diagram. The signal in that figure is multiplied by A in passing through the amplifier, then multiplied by beta in transmission through the feedback network, and is multiplied by -5 in the mixing network. Okay, such a path which takes us from the input terminals through amplifier feedback network back to the input is known as loop gain. The product minus A beta is called loop gain or return ratio. So here A beta or mod A beta, product of feedback factor and amplification factor, is called as return ratio. So the difference between unity and return ratio is called as return difference, that is D equal to 1 minus of minus A beta equal to 1 plus A beta. So in the previous block diagram, so the input signal is passing through the basic amplifier, then it is passing through the feedback network and getting back to the input, getting back to the mixture, so which is multiplying with minus 1. Therefore what will be the loop gain? Loop gain is nothing but minus A beta. So the path which takes us from the input terminals through amplifier feedback network back to the input is known as loop gain. Therefore the product minus A beta is nothing but loop gain or return ratio. Let us now tabulate the amplifier characteristics that get affected by different types of negative feedbacks. Okay, so let us see characteristics. What are the characteristics we will be considering? Voltage gain, bandwidth, input resistance, output resistance, harmonic distortion, noise. Types of feedback. So we have 4 different types of feedbacks: voltage series, voltage shunt, current series, current shunt. So voltage gain. So in voltage series, voltage gain decreases because AV equal to AVF equal to AV divided by 1 plus AV beta, therefore decreases. In voltage shunt, voltage gain decreases with feedback. Current series, voltage gain means gain decreases with feedback. Current shunt, gain decreases with feedback. Bandwidth, so in all these configuration bandwidth increases. Input resistance increases in all the configurations. Output resistance decreases decreases in voltage series, voltage shunt decreases, current series increases, current shunt increases. In the same way, input resistance in voltage series increases, in voltage shunt decreases, in current series increases, in current shunt decreases. Harmonic distortion decreases in all the configuration, noise decreases in all the configuration. So why input resistance in voltage series? Input resistance means input is series, therefore RIF equal to RI into 1 plus AV into beta. So whenever it is multiplied by the factor 1 plus AV into beta, therefore input resistance with feedback increases. So actually by seeing the connection at the input side, whether it is series mixing or shunt mixing, if it is series mixing, input resistance with feedback increases. If it is shunt mixing, input resistance with feedback decreases. Similarly, depending on the type of sampling, we can say whether its output resistance increases or decreases. If it is voltage sampling, that is nothing but parallel connection, therefore output resistance with feedback should be decreased. If it is current sampling, therefore the output resistance with feedback should be increased. So this is about general characteristics of negative feedback amplifiers. I hope students, you all understood the different types of configurations and their characteristics. Thank you.